Hi, fourth grade, it's Mrs. Boswell again, and we're on day 4 of wave patterns and information transfer. It says, I can model and explain how waves move. So yesterday we learned about wavelength and amplitude, and that's going to help with our model that you're going to be creating today. So waves. So remember earlier we learned and watched the video on waves. Here's a video. You only want to watch about 1 minute of it, so I'm going to play just a little bit of it. I want you to watch the waves. As you're watching those waves, you saw some that were larger and smaller. But I also noticed that my ears, the sound it was picking up, was the crashing of the waves. So it was moving through. You could hear the sound a little bit louder, maybe because those particles were moving through the water. Okay, because remember, sound moves. It can be heard faster when it moves through a more of a solid than through air, or gases like air. All right, oops, gonna play the video again. Give me a second. All right, so here we go. It says, obtain and communicate information. So I need you to pause the video, and I would like you to go get your science spiral notebook, and you're gonna be doing some writing today, and then adding pictures towards the end. So it says, inquiry activity, sound carriers. You will conduct an investigation to discover how sound travels through each state of matter. You will record observations as you conduct your investigation. It says, write a hypothesis. Which medium do you think will be able to hear sound through better? Air, water, or wood? And you're going to record your hypothesis in the form of an if-then statement. Okay, so here we go. So, using what you've learned from a hypothesis to describe how you can affect the amplitude and wavelength of a wave, use the if-then statement for a hypothesis. So in your journal, you can right now write what you think will happen. Do you think it will travel faster through air, water, or wood? Okay. Once you're done, you can click onto the next screen. So at home, the materials you needed: a rectangular baking tray, water, and a small plastic toy that will float. But actually, really what you need is like a stick. So you could go outside and get a small stick because you want to see how does it travel. So it says, be careful when using a rubber band. They tend to break easy. So if we had a rubber band from yesterday, you would be using that. Okay. So let's carry out our investigation. You're going to fill a rectangular baking pan halfway with water. Gently move the pan back and forth to create a series of waves. Create these 3 waves: short wavelength with low amplitude, long wavelength with high amplitude, and a short wavelength with high amplitude. Record your data. Draw an example of each wave that you created. Describe how you change the wavelength and amplitude for each wave. So here you're going to fill in these tables. So if I had a low one, did I hear sounds as it was sloshing through and moving? Okay, then on our next one, so you're going to write and draw what you hear and see. Okay, because that's going to take you back to that hypothesis of what you thought would happen. What does water travel through faster? Okay, this one says, now place the plastic item or your piece of wood in the water in the middle of the pan and record your observations of the motions of the objects as you create different waves. Okay, so create a different wave, move it around, and rate your findings here. Step 5, stop moving the pan and allow the object to stop moving. Record your data. Observe and record the position of the object compared to where it started in the middle of the pan. Record what you hear and see. Step 7, how did the waves affect the motion of the object you chose? What happened to that stick with the different waves? And then back to review your findings. How do waves travel? Think about the video of the different waves you watched at the beginning of the lesson. Explain how those waves travel from one point to another. So, once you've done all your recordings, I want you to put all your pictures on Seesaw, especially if you're at home and at school. You both need to do that because that is part of your grade that you will get. We want to see, what is your finding? Do you understand how waves move? Do they move faster through liquids, gases, or through a wood, a solid? All right. So if you're here at school, you're going to get a rectangular baking tray, water, and a cork, okay? And you're going to do the same thing. And you're going to be doing it all the same information from before. Once you're done, you'll make sure you submit a picture on Seesaw. Good luck today with your investigation.